this is the Chapter 10, Segment 4 outline, and this whole segment is related to Section 10.3, which is decision making and problem solving. So just to attribute a definition, decision making is the cognitive process of assessing information to select a course of action among several alternatives. And one aspect of decision making is judgment, which is the cognitive process of forming an opinion or making an evaluation by comparing possible actions. So the idea of looking at decision making in a lab is to get some insight into how we weigh different pieces of information in order to make a decision. So the first section of 10.3 is every judgment is subject to error and bias. So even random information can induce bias. So they give a lot of examples related to studies done on academia. So for example, just the teachers are given the exact same essay and are asked to grade them, and the essay found with the better penmanship received a higher grade even though it was the exact same essay. Another is SAT essay length. They found that the longer your SAT essay, the higher likelihood that the graders or official readers were going to give a better score. And another common example of this is home field advantage. So it might not be the advantage that players feel, but it might actually be an influence on officials. So the crowd or different information that they are receiving is influencing their decisions and often results in visiting players being more likely to be called for fouls or receive penalties. And this isn't because that they are trying to be biased, and it often means that in a close call situations, they're more likely to please the home crowd and slightly less to make them angry. And this is only because they're humans, and no matter how hard we try to make unbiased judgments, we're going to be swayed by our surroundings and any information that we have available to us. So this is related to the anchoring effect, which is the tendency to rely too heavily on an initial piece of information when we make a judgment. So a study was done to see how initial information, random information, can form a bias, and people were asked to spin a fortune wheel to get a supposedly random number, even though the wheel was rigged to either give the participants a 10 or a 65. So then they were asked the percentage of countries in the UN that are from Africa is less or more than their number, and then asked to estimate the percentage of African nations in the UN. So people who had spun to 65 were more likely to overestimate the percentage of nations that were people who had spun the 10. So exposure to a number biased participants' estimate, even though they believe that the number coming up on the wheel was random. So the next section is we are all prone to particular errors of judgment. And the big example in this section is the Monty Hall problem, which is an example of an error in decision making in which somebody fails to properly estimate the probability of an outcome after being given additional information. So let's say you're on a game show and there's 3 compartments and one holds a grand prize, such as a car, and the other 2 are gag gifts. So the book uses the example of 2 goats. So in box number 1, there's a car, and in box number 2 and 3, there is goats. So let's say you choose box number 1, and then Monty Hall or the host would say, okay, well, I'm going to show you what's in box number 2. See, it's a goat. After seeing this, would you like to change your guess? Or are you going to stick with box number 1? Now, Monty Hall knows what's behind each door. So if your initial choice was right, which will happen 1/3 of the time, then switching doors when Monty opens the other door will cause you to lose. But more often, 2/3 of the time, you will choose the wrong door initially, and then switching will cause you to win. So if you always switch, you will lose only when your initial choice was correct, which is 1 out of 3. So you actually have a higher percentage of winning when you do switch. The next is our hindsight seems so good because our memory is so easily distorted. So the first type of bias that we talk about is hindsight bias. So this is a tendency to misremember our previous views to fit our current knowledge or beliefs. And this is when people may believe that they knew the event was always going to happen. And if people believe their predictions were correct, when in fact they are not, then they may have an exaggerated trust in their judgment when it may be false. So an example that the book gives that was more recent was there was a book that claimed that women on average spoke more words per day than men, 20,000 words compared to 7,000 words by men. And it was widely reported on, and much of the reports were that this isn't really news, this is something we already know, that women talk more than men. But it later turned out that the author was citing someone who kind of guesstimated these numbers. And so when scientists directly tested the idea, they found that there was no sex difference in the number of words spoken per day. It's around 16,000 for both sex. So another example of this, another closely related bias is confirmation bias, which is a tendency to remember events that fit our preconceptions and to dismiss or forget events that do not. So a common example of this is the full moon myth, where people who may work in emergency rooms believe that their facility is especially busy during a full moon. But it turns out based on statistics, there's no real difference in emergency room activity around a full moon in the United States. So why do people believe this? It's probably because when an especially hectic shift falls on a full moon, they know and remember that evening, therefore forming this bias. So these two biases come together and feed into belief persistence, which is the tendency to hold onto a belief even in the face of contradictory evidence. This is very popular in politics, and it's often shown that there's not just that there are so many options for political commentary, but there's a lot of options consistently present in one type of view. So people can exclusively watch some sort of news source or political coverage that is only presented in their viewpoint. So the next section is we hate loss more than we love gain, and this is related to the framing effect. So just as a cognitive bias that occurs when the way information is presented makes a significant difference in what people will decide. So a famous example is people are told to pretend they're the CDC and they have to make a decision about how they're going to treat this town of 600 people who have this flu virus, and they're told if they don't do anything, all 600 people will die. So Group 1 versus Group 2, their questions are presented very differently. Group 1 is presented or framed in terms of positive results, so saving people, whereas Group 2, their pair of choices is framed in terms of negative results, so people dying. So the second choice, and in either of the groups are exactly the same, but the difference in what they choose is based upon how their questions were framed. So one theory is that we are reluctant to lose, but that when the question is framed around deaths, we are willing to take a risk to avoid any deaths. But when the question is framed around survivors, we aren't willing to take a risk to save more. And this is also seen in money, and this is related to loss averse. So the characteristic of being very reluctant to do anything that might lead to loss. So we don't like to risk losing, whether it's losing money or losing other people's lives. So in general, a choice presented with a positive frame, such as lives saved or money gained, is more likely to be taken than one presented with a negative frame, deaths, money loss, because we are loss averse. This is related to how the gambling industry sets up casinos and other sorts of places like this. And a kind of myth that gamblers live by, which is called the gambler's fallacy, is the belief that the outcome of random events up to this point will affect the probability of future random events. So people believe that if you receive bad cards in the last 4 poker hands, you're likely to draw a good hand in the next. This is no guarantee. And also the framing effect can have also an effect on our memory and our judgment in the way that things are framed. So this next section is problem solving, involves algorithms, heuristics, and representations. So the puzzle that is talked about in this chapter is the Tower of Hanoi. So this is a problem in which you transfer a series of different sized disks from one spindle to another following a specific set of rules. So this puzzle shares several characteristics of all problem solving. So there's an initial state, which is the situation at the beginning of a problem, the goal state, which is the desired outcome of a problem, and constraints, which is rules that you govern how you can get from the initial state to the goal state in a problem. So the solution, one of the solutions, or probably the most effective solution to the Tower of Hanoi, is an example of an algorithm, which is a specific set of steps that will always solve a particular problem. So if you follow this pattern or steps, you will always solve the puzzle. So the only problem with algorithms is that they can be elaborate and require many steps and careful monitoring of the outcome, which is perfect for computers but not always for humans. So that leads into heuristics, which is a relatively easy to follow set of rules that often but do not always solve the problem. So we more commonly refer to a heuristic as an educated guess or a rule of thumb. And then the last section of this chapter is, at least I'm pretty sure it's the last section, is strategies may help or impede problem solving. So another type of heuristic is availability heuristic, which is the tendency to rely on how readily an event comes to mind and judging its likelihood in the future. So that basically means if you can think about it, it must be common or important. So this works majority of the time, but it also can mislead us. So, for example, people often mistake or assume that you're more likely to be killed by a shark than by falling airplane debris. But in fact, Americans are 30 times more likely to die of fallen airplane debris than sharks attack. This is probably because of popularized movies such as Jaws. There's also working backwards, which is the problem-solving strategy of starting with the desired end result and reversing the steps needed to get there. It often helps to have insight, which is a sudden understanding of a problem that leads to the solution without resorting to trial and error. And then finally, choice blindness, which is the tendency of people not to notice when they have made a choice between two things and are subsequently told they had made the opposite choice.